Hi, today we're going to be talking about whether a relation is a function. We're going to be taking a look at if a graph passes the vertical line test. We're going to be stating the domain, range, independent, and dependent variables of a function. First of all, to get started, we want to talk about what is a relation. A relation is a set of pairs of input x and output y values. The relationship is written as an ordered pair x, y. Basically, a relation is just a bunch of ordered pairs together. In number 1, I ask you to graph the relation. I have the point 2, 1. I have the point 2, 0. Remember, the x comes first, so you go to the x value, and then you go up or down the y value. Negative 3 means I need to go over to the negative 3 and then go up 1. Not quite, there we go. And 6, negative 1. And negative 1, negative 4. So we have a bunch of ordered pairs on this graph, and that's a relation. Just a bunch of ordered pairs is a relation. Let's take a look if a graph passes a vertical line test. A vertical line test is a test where if I put a vertical line anywhere on the graph, if the graph hits that vertical line more than once, it's not a function. Like if you have points on top of each other, it's not a function. You see how these points right here, I put the arrows, all hit that graph? So this graph that's on here hits that vertical line more than once, so it's not a function. Let's take a look at the second one on this page, which is in problem number 3. It's a vertical line. So if I put a vertical line on top of it, they share every single point. This is not a function. A function cannot have can't have points on top of each other. And number 4, if I put a vertical line here, it only hits it once. If I put a vertical line here, the graph only hits it once, and here. Since it's only hitting a vertical line at one spot anywhere on the graph, this is a function. And then number 5, if I put a vertical line through it, it's going to hit it twice, and if it hits it twice, this one is not a function. And I use the abbreviation for function as a lowercase f with an n up in the air underlined. Let's take a look at the next page where I have a lot of examples of functions. Every single one of these graphs is a function. Notice that they all pass the vertical line test. If I was to put a vertical line anywhere on this first graph up here on the left, it would only hit it at one spot. Same thing on this graph. Anywhere where I put that vertical line, it's only going to hit it once. Same thing on this one, that graph, and as well as this graph. Now this top right graph is a little bit tricky. This is called a piecewise function. You see how this point is open? That means it's not included. You see how the one right here is solid? It is included. So if I was to put a vertical line through there, it's only hitting this lower point. The top point is not there. It's not part of the function because it was an open circle. Let's take a look at independent and dependent variables in relation to functions. Okay, my dependent variable not running to right there, variable. And when I write dependent variable, a lot of times in class, I'll just say the capital D and a capital V. The dependent variable depends on the independent variable. Whoops, not running to right. And my pen's not writing too well. So an IV, capital IV for independent variable. The independent variable is always my x variable. The independent variable, it comes first. It's what controls or predicts the outcome of the other variable. The dependent variable is the y variable. It is determined by the independent variable. The dependent variable is the output. It's what you get done once you put that x value in. At the bottom here, I have two examples that we want to take a look at. We want to be able to identify what's the independent variable and the dependent variable. Well, in number 6, if I'm talking about the hours and the salary, well, look at my hours. I go from 2 to 4 to 10, and look at my salary amount. It's increasing. The more hours I work, the more salary I get. So in this situation, my independent variable would be my hours. My dependent variable is my salary. My salary depends upon how many hours I work. Number 7, I'm looking at, on the x-axis, the hours boiling, and on the y-axis, I'm looking at the ounces of water in a pot. And I'm noticing that as time goes on of boiling this pot, the water in the pot is going to be decreasing. My independent variable is what I have control over, and that's how many hours I'm boiling it for. My dependent variable, how much water is in the pot, depends upon how many hours. So that's what's along the y-axis. Taking a look in word phrases, we want to be able to identify the independent and dependent variable here. At number 8, time in a mall to dollars spent. Well, sometimes the more time you spend in the mall, the more stores you're going to go into, and you're going to be spending more money. So my time is my independent variable. My dollars spent would be my dependent variable, because how much money I spend would depend upon how much time I'm in the mall. If I'm only in the mall for a very short period of time, I'm probably not going to spend as much money as I do if I had been there for quite a few hours. And number 9, miles driven to hours. Well, on this one, as the hours go by, I'll have driven further and further and further. So my miles depends upon my hours. So my hours is my independent variable, and my miles is my dependent variable. Number 10, the hours studied to the grade on a test. Well, if I take a look at the more time I put forth in studying, the better grade on my test. Hours and the grade. The grade depends upon how many hours were spent studying. So if the grade depends upon hours, the grade is the dependent variable, and the hours is the independent variable. 11, the height of a plant to months grown. We're looking at height, and we're looking to the months that it's been growing. Well, if a plant has been watered well, we'll be taking a look at it's been maintained well. As the months go on, the height of the plant should increase. So the height depends, so that's the dependent variable, on the number of months. What I'd like you to do is go back and circle all the independent variables. We've got time, hours, and months. What do they all have in common? They have a time in common. Let's take a look at the next page. We have a lot of writing to do on this page. So let's write a definition for a function. A function is a relation. It's a special type of relation in which for each x value there's exactly one y value. This word here, domain, is the set of all x values. It's all the input values of a function. It is also all the values of the independent variable. The range of a function is the set of all the y values, the output of the function. It is also all the values of the dependent variable. Okay, now taking a look at some relations, we're going to be looking at what we call a mapping diagram. A mapping diagram looks like the two ovals that you see, like the two purple ovals below. It shows how each member of the domain is paired with each member of the range. Now, first of all, I want to be able to identify what the domain and range is of each one of these, and then put it into a mapping diagram, and then identify if it is a function. My domain and I can use a capital D to represent domain, would be the -3, the 0, and the 2. And they should be written in numerical order. Now I use a capital D to represent domain. I use these fancy brackets around the -3, 0, 2, though you can't really tell they're fancy brackets with my pen. The range is all of the y values, so I use a capital R, fancy bracket, and then I put the range values in there, 1, 2, and 4, and they should be in numerical order. What I do for the mapping is I take the -3, I take the 0 and the 2, and the domain goes in the first box, the range goes in the second box, 1, 2, 4. And then I draw an arrow that hooks up from the ordered pairs. -3 was hooked with 1, the 0 was hooked with 2, and the 2 was hooked with 4. Since I only have one arrow coming from each of these domain values, it is a function, so I would answer yes. Try 13 and 14 on your own, and then turn the video back on and check to see if you did them correctly. Okay, compare number 13 with your work. My domain, when I identified, I used capital D equals, fancy brackets, then I'm going to write all the x coordinates of my points. That's why I have this -1, this 1, and that 4. My range would be a capital R, and I put all the y values in for the range, but notice that I only have this 5 written once. If a number repeats itself, either in the domain or the range, when you write it out, when you list it in those fancy brackets, you don't write that number more than once. Now my mapping with the 2 yellow ovals down here, I put my domain values in on the left, my range on the right, and notice again in the mapping, if a value repeated itself, like that 5 was twice, repeated itself twice up there in the relation, I don't need to write it twice down here. Now what I have is I have an arrow coming from the -1 to the 5, from the 1 to the 3, and the 4 to the 5. And as long as I have only one arrow coming from each of these domain values, it is a function. Taking a look at the last example, I've listed my domain as -3, 1, 5. Those were all the x values that were used in the relation up above and all those points. Notice the -3 was used twice, but it's only once in my domain. In my range, the 1 repeated, but it's only once in my range. In the mapping, when I go to write the mapping, remember on the left-hand side your domain, so you put all your x values, but if it repeats, you don't use that repeating value, and I put in all my y values. And then I drew an arrow to the coordinating points, like -3 went with 0, but -3 also went with 1. So I have 2 arrows coming off of this -3. That's what makes this not a function. Okay, remember, if the relationship is a function, there's only one y value per x value. Okay, last example. I want you to state whether each example is a function or not. Well, I only have one example. If it is a function, I want you to list the domain and the range. So we'll take a look at 15 and answer this question. Turn the video back on when you've finished. Well, when I look at this, if it's a function, I want to look at all of the x values. Are they different? If they are all different, then yes, it's a function. And I'm using my abbreviation for function. Yes, it's a function. Well, since it's a function, they want me to list the domain and the range. My domain would be all of my x values. My range is all of my y values. If they repeat, I only write them once, and I want to make sure that I put them in numerical order. So my x's, -5 is the smallest, then 1, then 2, then 8. My range, my smallest one is -3, then I have a 1, and then a 5, and then a 12. Alright, that's it for day 5.